Okay, good morning, students.
Good
Good
morning,
morning,
Good
ma'am.
morning, ma'am. Good morning, ma'am.
How many are joined? I'm not able to see all participants. Can you check?
ma'am. 10 participants.
Participants. Okay, I'll wait for 5 minutes. Are you able to see the full video? Hello?
Yes, ma'am.
Yes, ma'am.
On my screen, I'm just a smaller window. I'm not able to show the components or see all these components properly on my screen. So are you able to see Arduino board now? I am holding that in my hand.
Not able to see the Arduino.
Now?
No, ma'am.
No?
No.
Video is on. Can you see my video? Miss, can you
Ma'am,
see
all
your...
I'm seeing is starting Cisco WebEx meetings.
Okay. So current that is shared.
Akshay, change the view to side by side view. You'll be able to see the video as well.
Are you able to see video?
Yes, ma'am.
Everybody?
Yes.
Okay. So today's our first practical is to control the Viper using or Viper control system using Arduino. So that we are using rain sensor. So I'll show you the component. So this is the rain sensor. I don't know how you are able to or because on my screen I'm getting very short window of video. So I'm not able to even maximize that one. Okay, still I'll try to show you. So this one is the rain sensor that we are using, and along with this there is one more module. So this is the module which is representing the supply is on. That is this is actually the controlling unit. The rain sensor output is the analog output, and that if we want to convert that into digital, that ADC chip is on this. Apart from that ADC, we'll be having, you can observe this small potentiometer, precision actually resistor. Okay, so that precision resistor is to adjust the sensitivity of this rain sensor module. Okay, and this chip is representing ADC. That means the output of this rain sensor can be obtained in the form of analog as well as digital. Okay, so this is the sensor that we are using to just detect the water droplets here or the rain, and using servo motor on this motor we have just mounted this wiper, and we are trying to control the rotation and speed of this wiper. Okay, so this is considered as wiper. So as per the signal or as per the input obtained from this sensor module controlled. Okay, so I'll first explain you the code for this. I'll show you code. We'll go through the code. Okay, before starting, how many of you, I think everybody should know Arduino, but still Yeah, how many of you know all the features of this Arduino, or should I repeat it once? Shall I explain the pin configuration of Arduino?
I don't
No,
think
man.
Yes.
that is required.
I think many of you might have used this for your mini project. Okay, so the controller that we are using for this Arduino Uno, we are using Arduino Uno and the controller. So this chip is the controller. The controller that we are using is Atmega 328. Okay, so only the main things you should know is about the memory, the input pins, IO pins. Okay, the actually what are the pins which can be used as the PWM pins and interrupt pins and memory of this particular controller. Okay, so you might be open source board which has been basically developed for hobby projects, but now it is very widely used in all the applications. Okay, so this is very simple to use. Okay, it has 6 analog pins. Okay, 2 supplies we can obtain from this board. One is 5 volt and 3 volts. You can see these are the pins where we can get 5 and 3.3 volts can be obtained from these pins. Okay, there are D0 to D13 are digital pins, IO pins, okay, and A0 to A5 are the analog IO pins. That means 6 analog inputs I can connect at a time and can be processed. Okay, whereas 14 digital pins are there. Out of those 14, the first 2 are transmitter receiver. So serial transmitter receiver pins. Then 2 and 3, pin number 2 and 3, digital pin number 2 and 3 can be used as the external IO pins. Okay, interrupt signals can be connected through this 2 and 3, whereas 3, 5, 6, 9 and 11. So these pin numbers can be used for as a PWM. Okay, and talking about the memory, is this particular chip is having 30K, 32K flash, okay, where your program can be stored. It can be used to store the sketches. The program written in this Arduino are known as sketch. Okay, just like source program, source code we are calling in C. In Arduino, it is called as sketches. Okay, and those sketches can be just uploaded on this in the flash memory. Okay, so apart from this flash, it has SRAM and EEPROM. Okay, so SRAM is of 2K, which will be used for intermediate storage, and EEPROM for whatever is the permanent programs will be stored on the EEPROM. Okay, and that is having 1K. So memory is very less and hence very limited applications we can implement, or the applications which require very less memory can only be implemented using this Arduino. Okay, the supply for this Arduino can be connected from your USB, or it can be separately. There is a port given for the power supply. Okay, so this is the port where you can directly use the adapter. Through adapter, you can connect the power supply. So there are onboard LED is also existing, and the LEDs corresponding to transmitter receiver is also existing. So whenever your board is just giving some signals out or transmitting something, okay, so your transmitter receiver LED is also glowing, as well as this built-in LEDs to check the board, okay, so which is internally connected to pin number 13. So if you have given high signal for pin number 13, automatically that onboard LED will glow. Okay, and there is one reset button. Reset is temporarily we are holding the execution of program. We are not erasing the program from the chip. Okay, so reset is restarting the execution of program. Okay, so that can be done using reset button. Okay, so these are the features or these things you should know. Minimum these things you should know about your Arduino board. Okay, so as I said, memory is very less. That is, whatever is the temporary memory or temporary data that you are using in your program, if it is exceeding that 2K, so your program cannot be executed. Okay, so in that case, actually there is provision that you can use part of your flash memory. Okay, but the programming for that flash memory is something different. Okay, now for our application, we don't require much memory. At least, actually, we require very less memory to process our application, and hence we have selected this Arduino Uno. Okay, and now I'll just explain you the circuit diagram for this. Okay. So this is the interfacing diagram. Okay. Actually here the LCD is also connected, but while giving you demo, I am not connecting LCD because my LCD pins are not properly mounted. Okay, I cannot connect it properly. So LCD I'll show you in Proteous. So this is your rain sensor. We are using analog output from this rain sensor. As I said, this is the controller which is connected to this rain sensor. Okay, so rain sensor, it is acting just like a variable resistance device. Okay, so you can just see this rain sensor is nothing but it is coated with the nickel material. Okay, so just nickel lines we can observe on this, which are connected in series. Okay, so because of that, it is giving us very high resistance. Okay, and the output, when there is no water droplets or when there is no rain, the output of this particular module is high. Okay, so we are getting high voltage across these two terminals. Okay, so when you just put some water droplets on this, few of the lines get shorted. That means these serial lines will behave like they are connected in parallel, and because of that, the resistance of this particular device will be reduced, and hence the resistance across these two terminals will be reduced, and whatever is voltage we are getting, that will be reduced in proportion to your resistance. Okay, and that is how we are just using that value, the output voltage value obtained across these two terminals to just sense the rain intensity. Okay, so single that analog input connected to A0 pin, and this is the LCD configuration that I'll explain you in Proteus. And for the servometer, we require again only one output pin, but servometer we are using PWM pin because we want to set the angle of rotation. Okay, and for that we are using pin number 9 of this Arduino. This works on 5-volt supply, so servomotor requires supply. So 5 volts ground, as well as this particular controller board requires supply. So it is connected to 3.3 volts and ground. Okay, and on LCD we are printing the intensity of the rain, whether it is low, medium or high. Whereas servometer, based on the intensity, we are controlling the speed of rotation. Okay, so for every rain sensing, your servo motor should operate, but by what speed it should operate, that is dependent on the intensity of the water. Okay, so is there any doubt in this working? It's very simple actually. now I'll try to show the connections and working of this hardware, and then we'll go for, I'll close this video and then we'll go for the Proteus implementation. Okay. So as I explained, I already explained this board. Okay. So this is the Arduino. This is the servo motor, which has 3 pins or 3 wires, out of which 2 are VCC and ground. So this brown one is ground, middle one is VCC, and this orange wire is for PWM control. Okay. So those 3 wires through these 3 connectors are directly connected. I have taken that supply from the board, 5-volt supply from the board, ground, and this one is the PWM, which is connected to pin number 9. Okay. And the second thing is this rain sensor module through the controller. These 2 ports, as it is acting as the variable resistance module, the sensor. So there is no need to think of the terminals. These 2 terminals, anyway, you can connect it to the controller. This controller second end is having 4 pins, out of which 2 are for VCC and ground, and 2 are for analog and digital output. Okay. As the intensity of rain is continuously changing depending on the amount of water. Okay. So we are using analog instead of digital. Okay. So this one, the blue wire, is for analog. The green one is connected to VCC, and this yellow one is connected to VCC, and the middle one is connected to ground. Okay. So this is how this sensor module is connected to Arduino, and I'll just share that program. Okay. So this is the program. Arduino programming is just like it is similar to your C programming. Okay. So we have included here LCD interfacing as well as servo motor and your sensors. Okay. Are you able to see the screen? Arduino IDE.
Yes, ma'am.
Yes, ma'am.
So for Arduino programming, actually it is divided into 2 parts. One is setup, 2 functions we are defining for this Arduino programming. One is setup. Setup is usually used to define all the constants and to initialize all the interfaces that you have connected to your board. Okay. So and whatever are the variables that we are using, those variables either you can initialize or declare that outside the setup. Okay. So similar to the header files that we are including in C program, we are including header files here related to our components. So 2 header files are included here. One is to control or to operate your LCD display. Other is servo motor, and this is the function that you need to initialize. Okay, for LCD. Okay, what this is, we are actually I'll show you the circuit diagram in Proteus, and then there itself we'll discuss this LCD interfacing. Okay, for using servo motor, you require servo.h. You need to include the servo variable. So we are creating this my servo variable. Okay, which will be for this servo. Okay, and in this setup, so this is in position sensor values are the 2 variables that we are using in our program. Okay, and this is the setup where we are just initializing your serial monitor. Okay, we are initializing LCD. LCD that we are interfacing is 16 columns, 2 rows LCD. So that is specified that LCD.begin 16,2. Serial.begin 9600 is the baud rate with which we are transferring data to the monitor. So here you can observe that serial monitor. Okay. And then all these are the settings for your LCD. So initially we are clearing whatever is existing, LCD clear, LCD dot set cursor, setting the cursor where you want to display the message. Okay, so displaying initially automatically when you start upload the program, you will get this message displayed on the LCD automatic auto wiper system. Okay, and then just we are, this is everything related to LCD. Okay, just trying to print all these comments on the LCD. This is the user defined function. I'll explain after going through the loop. So loop is the function which is continuously running, which is continuously executing. It is as good as you can assume as the infinite loop. Okay, so loop is infinite loop. It is running as long as your board is connected, you're supplied to your board. Okay, so that program is keep on executing. Okay, so what exactly we have done in this loop is, again, the LCD cursor is set. Then second is we are reading the, this is the main important line in this. So we are reading the sensor value as the sensor is connected to analog input pin A0. So we are using command analog read, and whatever is the value at this pin A0 will be assigned to sensor value. Okay, the same value is transferred to the serial monitor through this command serial.println sensor value, and these are the conditions that are used to control.
Excuse me, ma'am.
Yes,
Ma'am, the screen is not visible.
Arduino screen is not visible.
No, ma'am.
Excuse me, ma'am.
You just scroll and check.
Ma'am, you're not the host now.
I'm
Somebody
not
else.
the host.
No, ma'am.
Ma'am, it's showing
Some-
Pranot as a host.
Pranot,
Yes, ma'am.
Yes, ma'am. It automatically happened. I don't know.
Yes, ma'am.
Pranot, you just disable the
I'll just leave it and then I'll join again.
And me into host. What do I do?
Okay, I'll join the meeting. We'll continue the same. Is it visible now?
No, ma'am.
No, ma'am.
No, ma'am.
Can you see me? Hello?
No, ma'am.
No. When I'm trying to share, it's giving me it's already shared. Just I close everything and I'll start meeting again. Okay. Are you able to hear?
Yes, ma'am.
Yes, ma'am.
Okay. So everybody can start meeting and you join.
Okay.
Now are you able to see the screen?
Yes, ma'am.
Yes, ma'am.
Let's start. Setup is done. So setup, as I said, all the peripherals to initialize your peripherals or the constant values. We are using this setup. Okay, this is as good as you are initializing, setting up the I/O pins. Okay, and serial monitor, LCD, starting of LCD, or whatever the hardware you're using to initialize those hardwares we're using. Setup loop, setup function, and loop function is acting like the infinite loop. Okay, which is continuously executing as long as your board is receiving the supply. Okay, so in this loop, okay, this one is different. Okay, the same program but written for Proteous. I'll open another one. Okay, so in loop we are just reading the analog sensor in out this input. Okay, so whatever is the value that is obtained from the sensor is connected to A0. So in this packet we have provided that A0. The analog read is the function that is used to get that value from the pin A0, and it is assigned to sensor value. Okay, and based on the sensor value we are taking the decision by what speed your wiper should rotate, and that is defined using function wipe. Okay, so the same sensor value we are printing on the serial monitor. Okay, usually if there is no rain, the value of that sensor or the voltage obtained across 2 points of those sensors is greater than 600. That is, as I said, it is giving you resistance, high resistance, and because of high resistance we are getting high voltage, and that value is coming out to be greater than 600. That will check. Okay, and if this is greater than 600, that means your motor should not run. That means wiper should not move. Okay, and hence for this my servo dot write, we are giving command to the servo to settle at the position, that is at 180 degrees. Okay, so then LCD, on LCD we are printing no rain or nil, and the same thing we are printed on the serial monitor. And if it is less than 600, we are calling this function wipe. Okay, so this is the user defined function which is defined before this loop, or you can define after the loop. Okay, so this is wipe function to which we are passing the sensor value. Speed is nothing but the sensor value that we are passing. Okay, so for example, here you can just check wipe sensor value. So this sensor value is assigned to the speed, and we are checking various conditions for the speed. If speed is greater than 400, okay, the sensor value is greater than 400, the speed value is set to be 5000. Okay, so and then we are just printing on the serial monitor that rain intensity is low. Okay, if this is in between, this speed is represented is given as 3000, and speed is less than 350, then speed is set as 500. So what is the significance of the speed that you'll observe from this delay? Okay, so these are the speed values set. That is, we are deciding, actually this is deciding the time delay. Okay, so after one wipe, that once your wiper has moved from 0 to 180 or 0 to 120, so after how much time it should again move, that is represented by the speed values. Is that clear? If it is greater than 400, the time speed is 5. You might, as I told, if the rain intensity is low, the value of sensor is high. Okay, so for higher value, longer time duration, time delay we are setting, and for smaller intensity, the less time duration we are setting. And this speed value is used to give the delay after every iteration. And this to follow is to move your wiper from 180 to 0 and again from 0 to 1. So this is representing the position of servo motor in position. Initial value set as 180. My servo dot write is writing that 180 and it is continuously decreased by 1. So it is representing the angle to which your wiper should rotate. Okay. So it will start from 180 because when there is no rain, we have set your cursor to 180. So it is starting from the initial position going to 0 or 180 if it is assumed as the horizontal, it is going to 0 and then from 0 it is coming back to again 180. This will be continued as long as your board is receiving the supply. Okay, is that clear? Program? I think there should not be any doubt. Program? If you're having any doubt, you can ask. Now I'll just show you the working of this servo motor. Okay. You need to do two things for connecting your hardware to the Arduino IDE. You need to first select the port. Okay. So through which you are uploading your program onto the board. Here I am selecting this port COM11. And then we are selecting the Arduino board also. Arduino board, which board you're using, you need to select that board. And now I'll just show the working of. I'll connect this board to the USB. I'm connecting this USB to the COM port. So you can see this is the servo motor. I have holded that in my hand. There is no rain, so it has at some constant position. Now we'll add some water droplets on this. Okay, so I'll just put here, and you can see your wiper is rotating after some delay. I'll just show you the monitor, serial monitor also. Can you see this COM port or the serial monitor?
Yes,
Yes,
ma'am.
ma'am.
So just check the reading. Now we have added only 1 or 2 drops. I'll just increase the water and you just observe the change, the speed also, and the value on this serial monitor. Okay, at the time. So speed is increased. Something happened with serial monitor. See, the value is 320, 327. So around it is representing high intensity. Okay. I just added those comments. I'll again upload the new program and I'll show you serial monitor again. Okay, it has done the uploading. No roll, no rain. It's giving you no rain. Okay. I think the program we have not changed the comment. I'm compiling it again and again we'll upload that. So any doubt in this? Actually, this is how your Viper control works. I'll show you just in uploading. And if you're having servo motor and Arduino at your home, so simply you can check. If you're not, I don't think everybody is having this REN sensor module. Instead of this, you can try by changing, giving some manual values instead of analog read and check the working of servo motor. And those screenshots you can just mail it to me. Otherwise, we will implement the same thing on Proteous. Then compiling, just upload that. Okay, done uploading. So it has done. Now I'll show you. See here, no range, and you're getting it's the value is. Can you see this COM port serial? Hello.
Yes, ma'am. Yes, ma'am.
Now that value is 622. I'll just put here the drop, a single drop, and that value has reduced to 386, and it's giving you low intensity. Okay. So see, it's now 186 to 33. It's still showing low. I think I have not changed it to high or other values. Okay. So in program we need to change. I just copy pasted that one in all the conditions. But you can observe here change in the values. So this is how, and you can just check accordingly speed. I'll just remove again the water. Again, it will come to the, it has increased, the speed has been reduced, and now completely I'll remove that one. Then it will show you need. It will take some time. I have just wiped out all the water from this rain sensor. Okay, so this is how your wiper control system works. Okay. Okay, now how many of you have installed the Proteus? So this is the circuit diagram for Proteus. Okay, uh, where you need to add all these components. You need to add Arduino. You need to add REN sensor module and all those things. Okay, so for that, are you able to see the screen Explorer?
No, ma'am.
No, ma'am. Only gray screen.
Only gray screen.
See, these are the components that I have downloaded. This is the rain sensor library for Proteus. Okay, so it comes with these three components. Once you install your Proteus, you need to copy this IDX and .lib file into the library. So that library you can find on C drive. You need to just unhide the hidden folder, and in this program data you can find this lab center electronics and this Proteus 8 professional under that library, and here you have to copy all IDX and leap corresponding to each hardware component, that is Arduino, REN sensor, servo motor is inbuilt, LCD that we are adding. Okay, so all those you need to copy paste in this particular folder. Again, I'm repeating, once you install your Proteus, that Proteus library folder comes under program data on C drive, program data, lab center electronics, Proteus 8 professional under that library. There you need to copy, and for Arduino, for REN sensor or wherever the programming for those hardware is required. Okay, so for those hex files are coming along with that. Okay, for example, ultrasonic. How ultrasonic works? It works based on the distance it has sensed. Now, in simulation, it cannot sense any distance. So instead of that, what we are doing is we are simply programming that particular hardware such that the voltage levels are considered as the distance. Okay, and for that you need to just add that hex file. So suppose I just consider this ultrasonic, you need to add this hex file to the corresponding component. Okay, I'll show you where you can just add this one. Are you able to see my Proteus screen? So this
Yes,
is the
ma'am.
subprogram we have already built on this. Okay. Okay. So the connections you need to just import it. You can just find here the library pickup devices where you can search for this. If I just write this Arduino, before writing this Arduino, as I said, you need to add those lib files, library files, IDX and lib into the program data, Arduino and library folder. Okay, then only you can find the device emulator. I'll click on. You can find all the Uno, Mega, and all those Arduino kits. You have to select one. Automatically it get added, and you need to click on the screen to add that component. Okay. Similarly, REN sensor module. Once we add this component into the library, if I just click here and type REN sensor, okay, you can find this REN sensor. Okay, click this, add it to the your schematic screen. Okay, and this is the virtual terminal which acts like your serial monitor. Okay, so right now this is not working in this, and as again it cannot sense anything practically, we are using this terminal which will be acting as the REN or no REN. So if it is set, it is the logic state input is connected here. So you can find again the same thing. You can either get it from here or you can find it from the library. Okay, so this is the component that is used to just give input to sensor. If it is 0, it is representing no REN, and if it is just, if I click on that, it will change its state 1, representing 1 as the input, which is representing there is some REN sensed by this module. Okay, so the output, digital output we are using for this simulation, as the input given is 0 and 1. It is connected to pin number 11, and servo motor is connected to pin number 9. Okay, and to execute this, actually you need to double click on this, and okay, before that again you need to compile your program. Now for Proteous, same program we can use. Okay, this is the program. Actually it is same program. Okay, only the thing is that this particular function I have modified because we are using only two logic states, 0 and 1. Okay, and one more thing you need to remember, you have to just click on files, preferences, and under this preferences you have to, usually it is not ticked, this compilation option is not ticked. You have to tick mark that particular option. Okay, so that we can find for the hex file. Okay, so just click on that and click on OK and compile this particular code. Once compilation is done, the hex file of this sketch get created, and you need to locate the path for that hex file, and we need to copy that hex file into the Arduino. So where to find, I'll just show you. You will find somewhere here. So this is the path where your hex file has been created. You can directly copy paste and copy from here and paste it into the address bar, so that you can directly jump to there. Now here, as already I have done it before, so the path is something, this temporary folder it has created 583492, and in that we'll find that file. So I will directly double click on this and just click on the folder to get the path. Path is already, we are there. No, we are not there. Okay. Just I'll cancel this one. I'll just copy and I'll show you the path. I'll just copy that in this address bar. And you can find so it comes with double slash. We have to make it to the single slash and just press enter. We can go to that particular file. So here it's giving you error because I directly included that hex file. Okay. So only till the folder we need to include. So this is the path where your hex file has been created. So you can just check this is the hex file for the program that we have just now compiled, and this particular path you need to copy and paste in the Proteus. So you need to paste it here, Control V, and then you need to actually add that hex file. Right? I have just added the path for hex file. Hex file is not getting added there. Okay. Just within 10 minutes I'll finish this. Okay, just a minute. Battery low. See users, app data, admin, app data, local. In that local temp, and in this temp there is a folder like this, and we need to copy this hex. Okay, and just click on okay. Similarly here you need to get the hex copy of REN sensor already there. From this Proteus library, that hex file, the third file you need to copy. The path for that hex file you need to copy paste for this REN sensor, and for servo there is no need, it is inbuilt. Okay, and this you need to connect. Okay, similarly for LCD there is no program or hex file existing for LCD. You need to simply copy the library files corresponding to LCD into that lab center. Okay, under program data. Now we have just compiled this one. We have copied the hex file onto this Arduino. Now I'll run the simulation, and you can just check. This is how your LCD works. Initially all the comments get printed and it will take some time. Now the status is 1, so it show you running. It will take some time. Actually here this virtual port is not working, but we can see in some other program, or maybe two signals are directly connected to this, and that is why your virtual port is not able to decide. See here, the status had changed to running. Now if I change this input to 0, so LCD gives you no rain. And one more observation, see here, raining, at the time of raining your servo motor is rotating. We can clearly observe here the motor is rotating. And after this 0, it will take some time to change the status.
Excuse me, ma'am.
हाँ बोलो.
Ma'am, you can start the serial monitor from debug.
From debug.
The last option, virtual terminal.
Yes. So rain here 0 value we are getting, but it's not changed over here. Okay. The digital output that we have obtained, status is 0. That 0 is displayed over here. Okay. So this thing you can try, and the screenshot of this you can mail, or you can just upload on the team. Okay. So this is all about our first experiment. If you're having any doubts, you can ask. If you are getting any problem in installing or uploading or copying the library files, you can just message me at any time or call me at any time. Okay. Okay, we'll stop here. So it is showing you now no rain. It is 1. And when it is raining, you can clearly observe your servo motor is rotating, and when that is 0, your servo motor stops. Okay. So proper simulation we can observe, and for this LCD you can just go through the pin diagrams here. You need to carefully connect all these terminals, that is 5 volts through potentiometer. We are connecting V and VSS and VDD. Okay, there is RS, reset, enable and read write. Read write is connected to ground, and enable is connected to the corresponding pins. If here I can read as it is, so that can be monitored as per the program. You need to connect those LCD lines, okay, LCD pins. So 2, 3, 4, 5, 6. So these are representing your data inputs. This is reset and this one is enable. Okay, the first is I'll just show you. The pins that we are using is this first one is representing RS pin. So RS is 2, enable 3, and these are the data pins. Okay, and that VCC VSS through potentiometer is required to control the intensity of LCD. Okay, so this is all from my side. If you are having any doubts, you can ask. Otherwise, we'll stop. What you need to do is you need to simulate the same thing in Proteus, and just get the screenshot of all these things and upload your screenshot on the team, okay, as lab assignment 1. And I already shared with you the PDF, the lab write-ups. So you have to simply write the FAQs, the post-lab questions, and upload that one. Okay. Any doubt? Okay. Then you can implement this. At least you can try this in the Proteus. Yes. I'm expecting everybody has to implement this in the Proteus and just upload your documents on Team. Okay.
Yes, ma'am.
We will stop now. I'll end this. Sorry, we extended it. See you then on Monday.
Yes, ma'am.
I'll end the meeting.